PPAP.
In this last video, I want to go through one sort of longer and more challenging problem about absolute versus conditional convergence. So let's look at this series, which we can call S, which is a sum from n equals 1 to infinity of -1 to the n minus 1 over times 1 over 2n minus 1 to the 1/3. So first, this -1 to the n minus 1 is a great sign that this is an alternating series. So we take the rest of the sequence that we're using to build our series and call that Bn. So we want to apply the alternating series test. So is Bn decreasing? That's the first thing we have to answer. And here, it's not hard to see that the answer is yes. You could do this with the first derivative test and show that this function 1 over 2x minus 1 to the 1/3 has a derivative that's negative. But maybe it's just easier to say that the denominator is increasing as n increases. So the cube root of 1 over 2n minus 1 is also decreasing. OK, so what about the limit as n goes to infinity of Bn? Well, for the same reason, this is 0. We're taking the 1/3 power of a bunch of numbers where the denominators are going to infinity. So we're taking cube roots of things that are getting smaller and smaller and smaller and smaller. So this is also true. You could, do something a little more formal to check that this is true, but I'll leave those details for you and say, what does this tell us? So by the alternating series test, S converges. So we want to know if S, now we know it converges, is it absolutely convergent or conditionally convergent? And this is the same question as asking, does S plus sum n equals 1 to infinity, where we put in the absolute value signs, does this S plus series converge? And we can rewrite this a little bit. What does the absolute value do? Well, it's just taking this -1 to the n minus 1 and turning it into 1. And we can write 1 over 2n minus 1 to the 1/3 as 1 over 2n minus 1 to the 1/3. So the question is, does this series converge? And now there are a lot of different things we could do to think about whether or not this series converges. This 2n minus 1 to the 1/3 in the denominator is a little tricky, right? I mean, we have 2n minus 1. Let's just look at the denominator to the 1/3. This is definitely a positive number. This is less than 2n to the 1/3, something a little simpler. And the smallest this is going to be is when n equals 1. Like this clearly is going up as n goes up. So we have a bunch of numbers that we're taking the cube roots of. If we cube them, they just get bigger. So this is less than 2n. But this question isn't really about a sum of 2n minus 1 to the 1/3. It's 1 over 2n minus 1 to the 1/3. OK, so here's the thing we really care about. This is now bigger than 1 over 2n to the 1/3, because if the denominator is smaller, that means the thing is bigger. And this is bigger than 1 over 2n, which is bigger than 0. So now we have this bigger sequence that we're adding up that we care about, and the smaller sequence, an. And we know that the sum n equals 1 infinity an, this is 1/2 sum n equals 1 infinity 1 over n. This diverges. This is a p series. with p equals 1. So we have this AN sequence and this BN sequence. The sum of the smaller things diverges. So the sum of the BN sequence, this also diverges by the comparison test. So I've said before that the comparison test is usually a little bit tricky to apply because you need to find a good sequence to compare your sequence to. I said the limit comparison test is usually easier to apply. But here, I actually think that it is easier to write down the function in the denominator, compare it to things that are close to it, but a little bit simpler. And then when you take 1 over those functions, you'll see that this works perfectly for the comparison test. So this is one of those cases where it's easier to apply the comparison test than the limit comparison test. OK, so what's the summary? S converges, S plus diverges. So this series S is conditionally convergent. So this problem is something that I put on the final exam when I taught Math 2B in fall of 2019. So this is the kind of absolute versus conditional convergence, longer example that you might expect to see on an exam.